Hello friends, today I am going to talk a little bit about the preparation of thematic maps, how to compose and lay out the map in ArcGIS. As a result of our previous exercises, we have developed the database and downloaded required attribute data from the concerned websites. So we have downloaded and cleaned the data which we downloaded from the National Geoportal of Nepal, managed by Survey Department. The data, spatial data, is in D drive, D practice drive of my laptop, and we have developed a practice geodatabase. Inside this database, we have dataset, and inside this dataset, we have layers, two layers, Palikas area, representing the local level administrative units of Nepal and some designated areas as polygons. And we can see how it represents the Palikas of Nepal. This is the preview of our database. So we just close it for right now. And apart from this, we also do have the data that which we downloaded from the National Statistics Office website, the results of Census 2021 data. In this data, we have total population, male population, female population, and we have calculated population density based on the area calculated with the help of our Palikas area spatial database. So we are going to use these two files to prepare our population density map. So let us start it, and before going to the details, let us see in this database how this population density data looks like. So let us make the graph for this data, for which we first sort out data, sort data on the basis of this popden column, population density column, smallest to largest, and it is arranged in increasing order. Now we can highlight this column, population density, and see how the graph looks like. This is useful for later on when we are classifying the local level units on the basis of population density for mapping purpose. So let us see the graph. Let us see this graph. The appearance of this graph looks something like this. It is more close to the standard harmonic or geometric graph. Standard G means either it looks more close to its H graph, harmonic, and the next one is the G, the geometric graph. In statistics, it plays a vital role in classifying the data. So now, for our population density map, we are going to use either harmonic or geometric series for classification of data. That's the purpose of making this graph. And every time when we are making statistical maps, we should look at these graphs and select the proper classification method. So now let us go to open ArcGIS. So I have this ArcGIS of my 10.8 version. You may have a different type of ArcGIS, different version of ArcGIS, but basically all the working procedures are the same. So once we have opened the ArcGIS, it displays like this, and this is the map data frame. Let us define the coordinate system and projection system for our map. we are going to prepare our map in Albert's equal area conic projection system using these parameters. False easting 500,000 meter, false northing 500,000 meters, central meridian 84, standard parallel first 27.0, standard parallel second 29.75 degrees of north latitude, and latitude of origin as 28.3780, 3361 degrees north latitude. After defining these things, let us apply this. Okay, click OK. Now we are all done to add the required layers for mapping purpose. For this, we add our spatial data, Palikas. Okay, it is here. And let us have a look at the attribute table. What we have inside this, inside the attribute table of this data. We can see the district name, local level name, CBS LID, which is the code for local level units, and district name written in Romanized version. Same local level units written in Romanized version. Types, type 73. It means this type 4 is the rural municipality. Type 3 is just municipality. Type 2 is metropolitan city, and type 1 is metropolitan city. And we have other standard shape length and shape area fields which we can turn off for our purpose. And this is the area, square kilometer area for the local level units. So it's okay, we have this information with us, and now we are going to add the attribute data. Attribute data we have in the Excel form. So for adding data, we go to Arc Toolbox. Then in Arc Toolbox, we go to data conversion tools and go to Excel. So we are going to import Excel in the form of table. So that's why we click Excel to table tool. Double click this. So in the window which opens now, we give the input Excel file. Let us show the input Excel file where it is. In our case, it is in practice folder, data, and the household and population Excel file. And the table will be formed at the location we specify here. Let us give the location D practice drive data, and we give as POP. Let us name it as household and population, table, and let us save it as table and click OK. Now ArcGIS will import the Excel table in the form of attribute table in ArcMap. So we can close these options, and let us have a look at the content of this table. Open this table, and let's see, we have local level name, CBS LID, which we are going to use to join this table with the attribute table of Palikas area. And these are the information from the census 2021. Now let us do the same. So now we first open the attribute table of Palikas area. So it is here, and let us go to options, table options, click, and join and relate. Let's click join, and join attributes from our table. the current table, this table, choose for relating, for joining to the attribute table, which select this CBS LID code, and in household and population table, we also choose the similar CBS LID field. So these two fields are common fields which relates the information present in these two tables. Let us click OK. So now see, it's instantly the information from this household and population table has been joined. This information has been joined to the attribute table of Palika's area on the basis of CBS LID field codes which is present in both tables. So this is how we attach or join the attribute information to spatial database. And now we are ready to symbolize the polygon units present in our spatial database based on the attribute data which may come from different agencies. In our case, it comes from National Statistics Office in the form of population density and other information. So now comes the important part. That is the symbolization of these polygons. We should show the information in a classified way such that the decision makers or map users can see the distribution pattern and grouping of different polygons, which makes them easier for decision making. So in our case, as we are going to use population density map, we should double click this Palika's area, and in layer properties we click symbology, and we have quantities here. And we take the value. We can take the value already population density. When this density if we haven't calculated this population density beforehand, we may use other solutions also for symbolization problem. So since we have this population density already computed, we symbolize all these polygons on this attribute. So as we have seen during the making of graph on the basis of population density values, we have decided that the graph of the data looks more closely, it matches with the harmonic series. The second one is the geometric series. And in ArcGIS, we do not have standard classification method which is similar to the harmonic distribution pattern, but we have geometric interval method which we can safely use for our data. Let us classify the data on geometric interval method, and let us take number of classes. We can choose it. So let us choose it 7 classes. So this way it gives some sort of classification to our data. Let us click OK. So OK, now we have these classes. So we can choose different types of coloring pattern. And in population density case, if we assume that the higher the population, it is not a good case for demography decision-making procedures. That's why we symbolize the higher density value polygons as red polygons, and lower or medium as yellow, and lower density values as green polygons. Let us choose this one, this color pattern. You can choose whichever you like, and let us little bit improve this symbolization pattern. For outline of these polygons, we take black lines, click OK. So now higher the density pattern, So in this symbolization process, if the density is higher, it shows green, which we do not want. We just want to reverse this process. Let's click it, reverse sorting. So now we have the correct order. The higher the density, the more red we should be allowed of these areas. And lower the densities, it's fine. And in middle, we have yellow or yellowish color. So this is the way we can apply, click apply and see how it looks like in the map. So look, in map, we have most of the polygons we have with green symbols, So these are the sparsely populated areas. So apart from this, while making the map layout, we are going to have a legend also for these things. So we improve this, format these legend labels, so that it's more user friendly, easier to read. We take only two values after decimal point. So now it looks like this. And there might be some other. Wait, it is changed. So we reverse this, and in this we format label with this. We pad with zeros. Okay, 1000 separators. We can use this 1000 separators. So now it looks like this. So we apply this symbolization pattern here. So okay, so you can see some white polygons here. These are the designated areas where we do not have population. So designated means the national, it may be national park, hunting reserve, and conservation areas, and so on maybe. So to fill up these polygons, we have one more layer, designated polygons. We have this layer. We add it and move it downwards, the palika, and symbolize this as a standard symbol for decimal parts. So we choose some sort of this without color, green color, normally for national parks. Outline also let us choose green, and background we can change background as no colors. So click OK, apply this. So if we apply this symbolization for this layer, so we have a complete map, complete polygons. All the polygons are there for whole country. Now this is one of the main parts in making the thematic maps. Properly symbolize the polygons or units we are going to map. So now with these settings, we are done in composing maps. So now we go to the map layout. Let's click this one. Let's go to layout view. Click layout view, and we are going to use A3 size paper probably. Yeah, let us try this. Go to paper size. Let's choose this printer. Choose A3 size paper. This is A3 size paper, and let's have landscape orientation. Click OK. So now we have this. So in this paper size, A3 paper size, we can accommodate our map at the scale 250,000. 2.5 million, sorry, 2.5 million, one more zero. So we can accommodate map like this. Yeah, 2.5 million. So to optimally use the available spaces in this, we can resize this frame Go to properties and go to size and position. We change this size position to position. These position are in inches form. Size coordinates. Okay. Size. So these are in inches frame. So let us check here what we can do. Go to properties, data frame, uses size and position, perspective, layers, indicators, data frame, no clipping. So we have done up to this, and we continue with making map layout. Let us see, we choose centimeters here, centimeters as units of measurement. Okay, click OK. Now we come here and we change the size of this frame. Go to properties, is size and position, and we reposition these things. For this we have 3.8 centimeter and 9.1, and the width and height should be 34.4 and 18.8. Let's see with this setting. Let's apply this. So it is changed. It has been changed, and we take this. Okay. We click OK, and let us customize this scale list 2.5 million. We add this to our list so that we can change whenever we want. 2.5 million. So now it is like this. And to make it a good map layout, we add one more neat line here outside this frame with the help of this rectangle. We can put this rectangle and go to properties, re-symbolize with no color, and this outline color, this one 0.01, 0.1, let us put. Okay, apply. Okay, and reposition this rectangle, size and position. Let it reposition at 3.1 x and y coordinate 8.6, and the width is 35.8, and then 19.8. So apply. Now we have like this. Yeah, we have one more line here. So, and one more line as a frame we put here again. We can just make a copy. This is a different way of doing the things. We can copy this frame and paste it and reposition it at, in our case, reposition it at 3 and 8.5, and this should be 36 and 20. So this way we have more professional like frame for mapping. So apart from this, we are going to put some information inside in this area also as well. So for this we take another frame and redefine its size and position. For putting some sort of text, we redefined it at 3.18, and the 2.48 with the size 14.13, 14.13 and 5.56 centimeter, and we can apply this. So we have one polygon here, and another one we can add later on. And to cover all these things, we can put bigger rectangle here and resize it, properties, and reposition it at 3 and 1.5 with width 36 and 6.8. Let's think. So in this place, later on we are going to put some information pertinent to this mapping. So now, apart from this, we need some sort of title. Title we should insert. It is in this menu. We can insert title for this map, which is in our case, we take capital and NEPAL. Nepal. Title is Nepal. So we can change the size as per our wish. Let us keep it 36 and make it bold. Nepal, and we insert the scale bar. Also we can insert, or just the scale as a representative fraction, whichever we like. So apart from that, we can put some other text also. So the text may be from our attribute table or some other text. Some other text. Similarly, we can put some other information also. North arrow, pictures, etc., whatever we need. So we just put a text here. And write this text. So the title of map, population density. Population density. Where is this? So we take it here and increase the size. Let's keep it population density. Okay. Size looks a little bigger. We can keep the size this way, and at the same time we can insert the scale bar also. So you can choose different options here for scale bar. Wide range of scale bars are here, or you can just keep map scale as a representative fraction. We can choose this one and click OK. So the scale is there. So now we have some professional looking map here. Apart from this, now let us make some legend. For making legend, we can insert legend from here. Legend. So Palika's area. Next. So legend. You can type next. Okay, next. So we make this size of the boxes in legend a little smaller. Let us take it 20 and maybe 20 and 12, 13. That should be okay. Even we can get be 20, 15 and 10. Okay, this is 70. Let's put 70 and 10. Next. So patches interval here, let us take 1 point and finish it. So this way we have legends here, legends. So we can put it here. If you want to reform this legend, you can just convert it to graphics and change whatever you want, the sizes maybe you want to change, etc. You have opportunity to change or edit this legend part. So now in this text box, this small box, we are going to enter the textual information, some sort of information on our map, on the theme of the map. So we have prepared a small text, population density text. We just copy this text. We can copy, Control C, yeah, or you can just copy from here also. Control C I have done, and we put this text by selecting so okay, text, we write here text, rectangle text. So it gives you opportunity to justify the text. So we paste here, so the text is here, we can apply it. So let us check whether it fits inside or not. So now let us see the size of the text by displaying in 1:1 scale. So we can increase the size of this box to some extent. So, and we can decrease the size of this text to, let's try 9. It doesn't fit. Let's take 8. So now it fits. So this way we put some information about the theme under consideration. So after that, it is reasonable to put some sort of table, detailed table of the information that we are presenting here. Since we have 753 local level units, we cannot put all information for all those local level units in this space. That's why let us just for trying, let's put the information for 77 districts of Nepal. So for this we can insert, object, so insert object, Pen plus Microsoft worksheet. So this Excel setup is open, and now let us open our data, Excel data, population density for districts. So we have made previously. We copy this information and paste it to this worksheet that has been shown here. Let's put it like this, make it a little bigger. So it looks like something like this in map. We have to reform it. So how we do is that we copy this title row 4 times, so that in each row we can put 20 rows, 20 information. So then we, from here, let us cut this information, and paste it here, and this information we take it out from here and put it here, and remaining this information we cut from here and paste here. paste here. Now we have all information in 4 set of columns. So to fit it properly, we just resize these columns to resize it. Column width to 2, so it looks good. And for districts, we resize them with column. I think 18 should be okay. So it's okay, it fits. And for all others, take this. So okay, that's it. And let's keep the remaining part as it is, or we can select them, double click, so it gives us more space. So this is the way we have reformat the table. And when we close this, so the table will be placed in our map. So okay, so we can close this. So table is placed here. Now it's our duty to resize this table to fit it within the specified area. So okay, here we can see different lines. So there are some problem. We can just delete it and try it once more. So many times we have to repeat the same thing several times due to some type of mistakes. We do it again. So no one is perfect. So I cleverly just copied all the information. Now I can I just have to resize the column sizes, and I am done. So let us resize to 2. Okay, this district name, let us resize all this column to 18. Okay, 18, and these we just auto fit them. Auto fit, and this also we auto fit. Oh no, yeah, we auto fit them. And so this is how it looks like. Now we can close it. The table is bigger in size. We can change the size of this table, to fit into our space. So something like this. Yeah, something like this. So now if we magnify, zoom this part, so you can read the information here. So apart from this, you can have some explanation of these shortcut titles in this space. So now let us see the map in whole. So now in this way, we are done with making the maps. There are some other options also, where you can put your individual capacity, individual knowledge to make more meaningful, pleasant looking map. So for example, you may put some information here, and copyright information you can write here, and map publishing date. If you wish, you can put your name also. So that way we are done with making some sort of map. The methodology is same for making other maps as well. The only difference is that you should collect the correct information from correct websites or correct sources. That's it. Let's hope I hope that you have learned a little bit from this video on how to make thematic maps. So I wish you all the best for the days to come, where you are going to make different types of thematic maps or other some sort of other maps also. Thank you very much for listening and being with me for this long time. See you in see you in next videos maybe sometime.